Alright, so this is just going to be a video on some examples of using the unit circle to find trig values. So for starters, we're going to do secant of negative 495. So when we are using the unit circle to find trig values, there's two things we need. The first thing we need is we need the trig function to be, I guess not first, you can do them in any order, but one of the two things we need is everything needs to be in terms of sine and cosine. Because remember, on our unit circle, x comma y is cosine comma sine. So cosine and sine are the only things we can actually pull off of our unit circle. I can't see secant on my unit circle, so I need to write it in terms of sine and or cosine. Well, secant is the reciprocal of cosine. It's cosine flipped. So the first thing I can do is I can rewrite this as 1 over cosine of negative 495 degrees. So now this is great. We've got it in terms of cosine, but negative 495 degrees, it's not on my unit circle anywhere. Right, my unit circle goes from 0 to 360 degrees. So what we can do, technically we could graph it. You could always graph it in standard position, right? And I'll do that real quick. We go around negative 360, then we go 90 more, and that puts us here at negative 450, and then we go negative 35 more. So we can see that the terminal side of negative 495 shares a terminal side with positive 225. So that's one way we can do it. But also, maybe you don't have a unit circle. Maybe you don't draw it out every time. So what you can also do is find a coterminal angle by simply adding, it's 95, adding 360 degrees until, and I guess I should do it kind of one at a time, until we get something that's positive and on the unit circle. So first I've got negative 495 and I add 360, and that gives me negative 135. Well, negative 135 is also not on the unit circle. So I add 360 again, and that gives me 225. That is on the unit circle, right? It's between 0 and 360. So now I can rewrite this. My next rewrite can be that 1 over cosine of negative 495 is the same as 1 over cosine of 225. Because again, if we were to graph negative 495 in standard position as well as negative 225, they would both end up with their terminal side here, which means that both of them are using this ordered pair for the cosine and the sine. So cosine of 225, well, cosine is our x-coordinate, so cosine of 225 is negative radical 2 over 2. All right, so we can do the keep, change, flip method here. However, we also remember that cosine is just, secant is just cosine flipped. So rather than doing this fraction over a fraction thing, we can just take negative radical 2 over 2 and flip it. So it becomes 2 over negative radical 2. Okay? Now that would be okay. And that's how it would simplify if you did the keep, change, flip thing as well. That's an okay answer, and I would accept that on the test. Something you'll see on the homework, however, is that they rationalize their answers, right? They don't like to have radicals in the denominator. So we multiply by radical 2 over radical 2. That gives us 2 radical 2. Well, radical 2 times radical 2 is 2. Negative 2, those cancel, so an answer you would see on your homework would be negative radical 2. These are the same number. If you were to type them into your calculator, you'd get the same thing. But on the final exam, you can leave your answer like this, right? I don't care about rationalizing, but that's kind of what the homework did, is it rationalized the answers. All right, let's try another. So this one is cotangent of 7 pi over 6. So for starters, 7 pi over 6 is on the unit circle. So that's good. We don't have to do any, messing around to get a value that's on the unit circle. but cotangent isn't on the unit circle. The only thing on the unit circle, remember, is sine and cosine. So we can rewrite cotangent. It's the reciprocal of tangent, but tangent's not on the unit circle either. So we want to rewrite cotangent as cosine over sine. Okay? Now everything can be found on the unit circle, right? I'm looking at this ordered pair because that is the ordered pair at the 7 pi over 6 angle. Cosine is my x-coordinate, so negative radical 3 over 2. Sine of 7 pi over 6 would be my y-coordinate, which would be negative 1/2. Okay, now we've got a fraction over a fraction, and we do need to simplify this. We can't leave it as a fraction over a fraction, but we also can't type it into our calculator because it's got irrational numbers in it. So the first thing I'll do is I will keep the numerator, change it to multiplication, and flip the denominator. My 2's cancel, and my negative cancels, so that just leaves me with radical 3. So my answer here is radical 3. All right, so this one, we've got cosine of 13 pi over 6. So for starters, we're good in the sense that it's cosine. It's on the unit circle. It's my x-coordinate. But the problem here is that 13 pi over 6 isn't on my unit circle. So we need to find a coterminal angle that's between 0 and 2 pi. And I say 0 and 2 pi because remember, now we're working in radians, right? Because it said 13 pi over 6. Everything's got to be done in radians. So what I can do is to find a coterminal angle, I can subtract one rotation around. So I can subtract 2 pi and see what I'm left with. See if it's between 0 and 2 pi. But this is a fraction, right? 13 pi over 6 has a denominator of 6. So I need to rewrite by multiplying 2 pi by 6 pi over 6, right? I haven't changed the value. I'm technically multiplying by 1. I need to rewrite this as 12 pi over 6. Because now that they have a common denominator, I can combine the fractions. 13 pi minus 12 pi over 6. 13 pi minus 12 pi, those are like terms. You can think of it like literal pi. I have 13 pi's and I take 12 pi's away. I'm just left with 1 pi. So the answer here, the coterminal angle, would be pi over 6. So that means if I was going to graph this in standard position, it would look like this. Okay, so I can rewrite this now as cosine of pi over 6. These two things are equal. If you were to type them into your calculator, you would get the same answer. You would get a decimal answer, which is why we don't type it into our calculator, but they're equal. They're the same. So now all I have to do is look at my unit circle, look at pi over 6. It's cosine, so I'm looking at the x-coordinate, and bam, there's my answer, radical 3 over 2. Okay? One more example, cosecant of negative 5 pi over 4. Okay, so the first thing is cosecant is not in terms of sine and cosine. Cosecant is the reciprocal of sine. So I'm going to rewrite this as 1 over sine of negative 5 pi over 4. Okay? Second thing I need to do, negative angles aren't on my unit circle. So I have two options. I can either draw negative 5 pi over 4 in standard position. So knowing, okay, I would go pi over 4 in the negative direction, and then 3 pi over 4 in the negative direction, then 5 pi over 4 in the negative direction. So one way I can do it is just by drawing negative 5 pi over 4 in standard position. The other way I can do it is, again, finding that coterminal angle. So I can do negative 5 pi over 4 plus 2 pi. But again, we need a common denominator, so I'm going to rewrite 2 pi as 4 pi, 8 pi, 8 pi over 4, right? Negative 5 pi plus 8 pi, over 4 is going to be 3 pi over 4. Okay, so regardless of whichever way or whatever way you figure it out, you should have figured out that this is the same now as 1 over sine of 3 pi over 4. Okay, now it's a value on my unit circle. Now I can look at 3 pi over 4. I can look at that ordered pair. My sine is going to be the y coordinate. So this is going to be 1 over radical 2 over 2. Okay, we can use the fact that it's technically a fraction over a fraction, right? That's technically 1 over 1, and we can keep change flip. And then get that my answer is 2 over radical 2. Or you can go back to the idea that cosecant and sine are reciprocals. So you could just take sine, flip it, and that would give you cosecant. Right? Again, this is one where on the homework or on the internet sometimes they might rationalize it. So you might see this answer as radical 2. Both of those are correct, right? Most of you are probably likely to give this answer, and that is perfectly okay.